Sir, good afternoon, sir. So, good afternoon, everyone. We are gathered here for the 11th session of the Faculty Development Program, Green Energy Technologies and Sustainable Technologies. So, we have respected professor from IT Roorkela. Oh, sorry, sir. One minute, sir. Sir, are you able to unmute, sir?
Yes, sir. Yes, sir.
Yes,
Is it
sir.
audible?
Clearly audible, sir. Please, sir. So, we have Dr. R. Murugan, Professor, Department of Mechanical Engineering, NIT Roorkela. We'll give a short introduction to him. So, Dr. S. Murugan is a professor in Department of Mechanical Engineering, NIT Roorkela, NIT Odisha, who is having rich expertise in internal combustion engines and energy engineering. He has carried out extensive experimental and analytical studies on alternative fuels, thermofluid systems, and cleaner energy technologies, contributing over the 100 research publications and even patents on improving the engine power to weight ratio. He has successfully led sponsored projects on biodiesel-based engine applications, diesel engine applications, and coordinated several high-end workshops, faculty development programs, and conferences in thermal engineering and sustainable energy. So we are today greatly privileged to have him with us, Dr. S. Murugan, who will share his insights on this faculty development program on the theme of green energy technologies for sustainable development. It is organized by our Department of Mechanical Engineering at Veltech Meditech, Dr. Rangarajan, Dr. Shakuntala Engineering College. Sir, we warmly welcome you, sir. You may present your slides. Title is a little different, but you can take over the session, sir.
Thank you very much. Thank you very much, sir. Can I share this screen now? You have to allow me. When I am sharing my screen, you have to allow me that. Hello? 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 Sir, please allow to share the screen.
You are okay to share the screen, sir. No one else is sharing the screen. I switched off my shared screens. Yes, sir. Present.
Can I start now?
Visible, sir?
Yeah, visible.
Visible, sir.
Shall I start now?
Clearly visible, sir.
Shall I start?
Yes, sir. Please start, sir.
Okay. I thank the organizers for giving organizers of this faculty development program for giving me an opportunity to talk on this topic, hydrogen fuel for cleaner mobility. Is it audible and visible? Hello? 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 Is it audible? Hello? 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 Is it audible? Hello? 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 Hello?
Wait, sir.
Sir, is it audible? Hello? Hello?
Even I could not unmute. What is happening?
Hello? Sir, I'm starting my presentation. The topic of my presentation
Yes,
is hydrogen fuel for cleaner mobility. As you know that there are few primary fuels, primary energy sources which are consumed in every sector, like electric power generation, transportation, residential and commercial and industrial sector. If you just look at this figure, electric power generation it consumes about 36% of the primary energy sources, followed by transportation sector. It consumes about 30% of the primary energy sources, then followed by industrial sector, which accounts for 20% of the primary energy sources consumption, and finally residential and the commercial sector consumes about 13% of the entire primary energy consumption, energy sources consumption. So if you just look at this right hand side, the oil, petroleum fuels alone, how much it is consumed in each and every sector, it's mentioned, is indicated in the pie chart. Right hand side, you can look at that. So if you take this road transport itself, it is a major share, which is about 54%, and then followed by other industry and non-energy consumption, then followed by other transport sectors, which is about 11%, and remaining goes to other services, other application services, industry, minor industry, and essential industries. So the fossil fuels, it plays very important role in transportation sector. If you look at this chart, bar chart, which indicates the coal consumption in each and every sector, from electricity to other utilization, how much energy is utilized in the transportation industry. Let's say electricity, coal, LPG, compressed natural gas, fuel, ethanol, jet fuel, fuel oil, diesel, and gasoline. So over the last 20 years, from 2010 to 2016 itself, there was a gradual increase in all this fuel consumption, and it is expected to still grow and increase further, almost 1.5 times of that 2010. So if you see this every year, of course, last 25 years, the emission pollutant emitted by various vehicles in world that increases abnormally. Therefore, each and every country introduces the emission norm. Let's say actually India, it follows the Bharat emission norm, whereas the other prominent emission norms proposed by different countries are United States, Canada, Japan. There's some voices coming at the back. Turkey, Mexico, China, Brazil, Australia, Russia. Of course, India follows the European norms. Yeah, they call it as Euro norm, and the name is Bharat. But if you see this worldwide, the United States, it follows stringent emission norms. If you see here, since we follow the European standards, it started with Euro 1, and now it is about Euro 7. But in this pie chart, it is shown up to Euro 5, how the timeline of heavy duty emission standards are followed right from 2012 to 2024. So the transportation sector, it plays very important role in any economy, industrial economy, or and as well as country's economy. As you know that the transport vehicles are a different type. It may be a two-wheeler industry, a two-wheeler vehicle, or three-wheeler vehicle, four-wheeler vehicle, whatever it may be. On road, you can see different vehicles are there, like bike, car, taxi, taxi, tractor. Also in villages, of course, people are using for mobility. Then, of course, the truck, everything is there. In the peculiar one, in Australia, we use a road train that is shown in the right hand side of the picture. Road train, also known as land train, or it's also called a long combination vehicle, which is used in especially in Australia, where 2/3 of the area, land area is covered by desert. So in the land area, train tracks will be there, and in desert, of course, the train tracks will not be there. In that case, in both the cases, this vehicle right hand side shows the picture, that is a road train that will travel. Only in Australia, this kind of long combination vehicle or road train is used. And of course, for mobility, we also use railways. Early days we used steam locomotives, whereas now we use diesel operated or electromotive engines, which are propelled initially by diesel, and then diesel engines are fitted. They generate electricity, and that is given to electric motor. That electric motor will, of course, propel train. Of course, nowadays we also have direct electric shunt motors which are used to propel the vehicles. In the sea transportation, of course, you have different types of vehicles like yachts, ship, boat, and of course cargo ships. All, of course, they use the engines. Primarily, they use internal combustion engines. Of course, nowadays we also use electric vehicles, electric motor operated vehicles. The sea transportation. And air transportation, you know very well that it's of course aircraft engines are used. Now, when you come to this, I think it's hanging. Hello, hello. So when you come to this transportation industries, of course, we primarily use internal combustion engines. So although internal combustion engines are very much useful in transportation sector, we also use other prime movers. Now look at this different prime movers, what you get, what you are able to see. Internal combustion engines. Hello. Hello. Internal combustion engines, of course, gas turbines, hydro wheels, of course, the fuel cells. All these are used in transportation sector nowadays. When you see this global transportation demand by fuel, actually, primarily the petroleum fuels are used majorly. That's gasoline, diesel, which are the primary fuels used in transportation sector in all automotive vehicles, followed by, of course, fuel oil, jet fuel. Then, of course, natural gas now slowly replacing some of the substituting. Natural gas is substituting the petroleum fuels. If you go to metros like Delhi, Bombay, Bangalore, and all, you can see natural gas vehicle as well as LPG vehicles are coming up. And of course, other fuels like LPG, they are coming in passenger vehicles. So slowly we are replacing the petroleum fuels by alternative fuels. It may be natural gas, LPG, or of course electric vehicles. Nowadays we are able to see a significant population of electric vehicles both in cities as well as rural areas. So the cost of the petroleum fuels, especially gasoline, is compared with the cost of hydrogen and electricity is compared in this table. If you just look at it over the from 2010 till 2030, what is the anticipated or expected fuel price that is shown here. You see this gasoline
it is 12.7 US dollar per liter per gigajoules. And in 2030, minimum it is expected that it will be 19 US dollars, and the highest is expected to be about 38 $38 US dollars per gigajoules. Whereas if you see this hydrogen, it is 42 $42 US dollars per gigajoules, and in 2030 it is expected to reduce about 35 US dollars. Whereas if you see this electricity, that will remain same from 2010 to average of 2030, which is about 36 US dollars. So there is a scope for replacing this gasoline with hydrogen. Now, if you see this, the entire world is looking for alternative fuels which are green as well as cleaner fuels. If you take green fuels like biofuels, they are used in transportation sector like ethanol, biodiesel, all are green fuels. And the cleaner fuels, if you see, hydrogen is one of the important cleaner fuels. And of course, that can be used in another device called fuel cell that also can give cleanest or zero pollution from the automotive vehicles. Actually, electric vehicle also it is cleaner mobility, cleaner vehicle. But if you compare this hydrogen and the fuel cell, electricity bound vehicles, they may give the net CO2 emissions higher than what it is produced from the hydrogen bound engines or hydrogen bound vehicles or fuel cell bound vehicles. Why it is? Because you can use electric vehicles either in the city or town or rural areas, but the amount of electricity used for all the vehicles, that has to be produced by different power plants. So power plants normally normally consume coal as a major source. In that case, power plants will generate a lot of CO2, and that will create local emissions, local CO2 emissions, which will be higher than the present one. Therefore, electric vehicles also, they may indirectly contribute to increase in CO2 emissions. But if you see this hydrogen bound internal combustion engines, they will not produce that much CO2 because H2 hydrogen, it doesn't carry or contain any carbon in the fuel. Therefore, nowadays automobile manufacturing companies, they are trying to use hydrogen as much as possible in internal combustion engines because of zero emissions. And of course, the electric vehicles can only replace certain amount of vehicle population. But all internal combustion engines cannot be replaced with electric power. Therefore, the cleaner fuel like hydrogen will play important role even next 50 years. BMW, in a recent news, BMW says goodbye to electric cars, and it will try to roll back to manufacture hydrogen engines because the reason what I told, electric vehicles have different technical problems. At the same time, the energy consumed by electrical energy consumed by the electric vehicle, that has to be provided by different various power plants, which may increase local CO2 emissions day by day. That's why they want to roll back to the hydrogen engine manufacturing. So, if you see this greener fuel and the cleaner fuel, if you see this greener fuel, as I told, we use biodiesel in diesel engines, diesel cars, and bioethanol or ethanol fueled vehicles in petrol cars. There, of course, they are called greener fuels. But if you see this cleaner fuels, as I told, hydrogen is one of the important cleaner fuels. When you use this hydrogen in a fuel cell, that will also create a zero emission. Therefore, the entire world is focusing on to how to use this hydrogen in automotive vehicles for transportation application. Not only hydrogen, fuel cell also. So if you just look at this figure, the right hand side bus, it shows fuel cell bus, which was in Australia, and the bottom below figure, hydrogen is filled in a fuel station. Hydrogen is filled to a passenger car in a fuel station. So now people are trying to integrate hydrogen, hydrogen IC engine, hydrogen fuel cell together in a vehicle. That's called hydrogen fuel cell vehicle, hydrogen IC fuel cell vehicle. Again, some people they work on hydrogen fuel cell, hydrogen fuel cell, and electric vehicle. So the Western countries they are slowly moving on to use hybrid vehicles in nature that may use both of this hydrogen engine and fuel cell, and electric vehicle like this. There, by doing that, you may get a very reduced or cleaner environment in that areas. Therefore, the entire developed countries they are working on to change the mobility, especially passenger vehicle operation into this mode. That means hybrid mode. Some of them they are still trying to work on tribrid. Tribrid means IC engine, means IC engine operated with a greener fuel plus electric vehicle plus hydrogen fuel cell. That way people are working. Now one can say that of course I will use this hydrogen. I want to use this hydrogen in my vehicle. Then what are the necessary arrangements I have to do before going to apply your hydrogen as a fuel in transportation vehicle? What are the things you need to do that you have to understand? Now, before that, one has to know what is the characteristics of hydrogen, because we are habituated to use gasoline and diesel, which are used in petrol and diesel engines. But now we are slowly transforming to use alternative fuels. Then what is the difference between hydrogen and other substitute fuels like biodiesel, ethanol, all the things? If you compare this hydrogen with the greener fuels like biodiesel or ethanol, they contain some carbon in those fuels. But hydrogen, it is a carbon-free fuel, so it will not produce any carbon-based emissions when it is burnt in a combustion engine. So hydrogen, actually, when it was invented by a Swedish scientist called Cavendish in 1810, the hydrogen was named as a water creator. And as you know that hydrogen is a two molecule substance and it can quickly react with oxygen to form water. So when you combine this hydrogen with oxygen, it will not produce any other substance except water. So if you see this hydrogen, it's a colorless, odorless, and non-poisonous gas, and it is lighter as well compared to other fuels. But the problem is, since it's lighter, the storage tank what you require to provide in the automotive vehicles, that will be larger than the IC engine what it can use petrol tank or diesel tank. So in that case, people are working on to reduce the size of the engine, size of the storage tank by different methods. Hydrogen, of course, it can burn with a pale blue color. Almost it is invisible. It will be an invisible flame. And if you want to store hydrogen in liquid state, you have to store it in minus 253 degree Celsius. 253 degrees Celsius. So in that case, it's very difficult to store this hydrogen in liquid form. Now, people are trying to store this hydrogen in metal form. That's called metal oxide. Metal hydride. Then you can use that solid form. people are trying to use this hydrogen in a gaseous form, and as it is, they allow it in the engine. That also they are doing. By that way, we will see how we can use this hydrogen in internal combustion engines. Now, what are the merits of hydrogen? Of course, it has high gravimetric energy density, and of course, hydrogen is one of the most abundant elements in the form of chemical compounds. You can get hydrogen easily. That I'll tell you how it can be produced, and there is no harmful combustion products you will get when it is burnt in a combustion when it is burnt with oxygen in a combustion chamber or in a combustion device. Therefore, it is treated or regarded as one of the important and environmental friendly cleanest fuels in the world, and it can be produced. It can also be produced from a variety of sources, right from biomass to water. That means nowadays water is the main substance and the electrolysis process by which we can produce hydrogen from water. But when you have scarce of water, then there you cannot produce hydrogen. Therefore, people are trying to explore different ways by which we can produce hydrogen from various feedstocks or various raw materials. And if you see this demerits, of course, it's wrongly written. Demerits, it has low volumetric energy density. That means it is lighter. So it requires a bigger size tank, fuel tank, if you want to use it in hygiene. And it is highly flammable. Means it can catch fire. Suppose you take this LPG stove in your house. LPG, if you show an igniter lighter, then say within 1 feet it can catch fire. But if you see this hydrogen in a long distance itself, it can catch fire. That's the problem, because its flame velocity is higher. So hydrogen is unsafe to handle when you use it in hygiene. And the third one is difficulty to store hydrogen either in liquid form or gaseous form. That's why people are working on to store hydrogen, how we can store in a safe way. So if you see this hydrogen, earlier hydrogen was produced only from water through electrolysis process, but now hydrogen production is one of the booming industries in the world, and it is produced from different sources. Therefore, there are different color codes given for hydrogen based on the method of production. So if you see this, now hydrogen production or hydrogen is given in different colors like green hydrogen, pink hydrogen, yellow hydrogen, turquoise hydrogen, brown hydrogen, blue hydrogen, white hydrogen, like this, based on the method by which hydrogen is produced from several sources. So if you see this world hydrogen production and utilization as of now, if you just look at this left hand side of the figure, actually hydrogen is produced. The main method to produce hydrogen is the coal followed by natural gas, then electrolysis and oil. If you just look at this, the conventional method of producing hydrogen is, of course, coal or natural gas. Electrolysis is also used. But the problem with electrolysis is that it requires water, which will be broken into hydrogen and oxygen by supplying energy. The supply of energy also, it is taken from electricity. Therefore, electrolysis process, it's a energy intensive process. So energy consuming process. So people are trying to use renewable energy sources like solar, wind to produce electricity, and that electricity is used to produce hydrogen. That means crack water into hydrogen and oxygen. When you take this coal, natural gas, they are all, of course, fossil fuels. Oil also fossil fuel. and they can be broken into hydrogen, or they can be derived, they can be converted into hydrogen by different methods. I'll come to that later. And when you take this hydrogen utilization, as of now, hydrogen is used primarily for ammonia production and methanol production, and then it is also used in refining process and other applications. So the accountability of hydrogen in transportation application is, as of now, it is very, very less percentage, and people are trying to explore the possibilities, various possibilities of using hydrogen in transportation application, especially mobility, to a greater extent in near future. So if you see this, the global demand of hydrogen in different sectors over the last 50 years, that means 1975 to 2018. So how the trend is there for the global demand of hydrogen. If you see this, as I told, hydrogen is primarily used in ammonia production, then of course methanol production, and the other industries like refining, other industries like other industries. So if you just see this, the ammonia production, which requires lot of hydrogen, and it was it was increasing ever over the last 50 years. Same trend is shown for other applications also. So the importance of hydrogen is very well understood by seeing this slide or picture. Now one can ask, already we are using petrol and diesel, and why, how we can have this hydrogen in Western countries. Some of the Western countries and USA and all, hydrogen is stored in the fuel station itself. After producing this hydrogen from coal industry or refinery industry, but countries like India, we are still far behind in producing hydrogen. Then what are the pathways for producing hydrogen? Here I have given a chart. There are two sources what we can use to produce hydrogen. One is fossil fuel and the second one is renewable energy sources. Fossil fuel means, as I told, coal is the primary source or raw material from which we can produce hydrogen. And then of course natural gas. From natural gas also you can produce hydrogen. So when you take this fossil fuel, hydrogen can be produced through two different routes. One is hydrogen reforming and the second one is hydrocarbon pyrolysis. If you see this hydrogen reforming, there are three different ways by which hydrogen can be produced. One is steam reforming, second one is partial oxidation, third one is autothermal reforming. On the other hand, if you use this renewable energy sources, actually there are two main methods used. One is the use of biomass processes, and the second one is water splitting. Water splitting means simply break this water, break water by supplying electrical energy. It can be converted into hydrogen reaction, because H2O, chemical formula for water is H2O, and if you crack this water, it will give you H2 and O2 by electrolysis process. However, you need certain amount of energy to break this. So water splitting is the main method by which you will get hydrogen. As I told, since we are using electrical energy, that electrical energy can be first produced from various renewable energy sources like solar and wind, and then it is used to split water. So water splitting has three different methods. One is electrolysis, then second one is thermolysis, third one is photolysis. When you come to use this biomass processes, different processes can be adopted. Mainly they are classified into two. One is hydrogen reforming and the second one is hydrocarbon pyrolysis. When you take this hydrogen reforming, you have three different processes called biophotolysis, second one is dark fermentation, third one is photofermentation. Under the hydrocarbon pyrolysis, we have pyrolysis, gasification, liquefaction. Therefore, based on all these processes, one can increase the hydrogen production. Solar energy, people are working on to introduce solar energy to get hydrogen production, to get hydrogen, so that hydrogen can be used in automotive application, not only automotive application, wherever we can use this hydrogen in prime movers. They want to use it. Then how solar energy can be utilized to produce hydrogen? Actually, here also there are different pathways. One is heat. Solar energy can be used to produce heat by using collectors, and that heat can be converted into that heat can be utilized to produce hydrogen via thermolysis process. And the second one is the same heat what you get it from the solar collector, that can be converted into first mechanical energy, then it can be converted into electricity, then that electricity can be used for electrolysis process to break hydrogen, break water into hydrogen and oxygen. Then different energy renewable energy sources like wind, ocean, hydro, geothermal, they are all indirect form of solar energy. They can be used to produce first mechanical energy, then electricity, then of course the electricity can be used to break water into hydrogen. Then solar energy can be directly converted into electrical energy by the use of photovoltaic cells. Photovoltaic cells can get electricity with maximum efficiency. That electricity can be used to break water into hydrogen and oxygen. And then the fourth route is the use of biomass. Biomass can be converted into fuels, or that can be converted directly into hydrogen. There are two different routes used. One is biochemical conversion of biomass, and the second one is thermochemical conversion of biomass. With that, of course, we can get a hydrogen fuel. And the next one is photobiological process, by which you can produce hydrogen, and the last one is photoelectrochemical process, by which you can get hydrogen through enzymes, bacteria and all. That's called a photobiological process or a photoelectrochemical process, photolysis. Photobiological process. Then photoelectrochemical process, in which of course similar kind of method we use to get photolysis and get hydrogen. So as I told, nowadays we use different colors, color codes to indicate a hydrogen, which is produced from different sources. So this table shows the color codes of hydrogen, other names also given, and what is the production method that's given shown in the third column, and the last column it shows what kind of energy source is used in that production method. So here, of course, primarily I'm just showing 7 color codes. The first one is green, second one is blue, third one is black, fourth one is pink, fifth one is turquoise, sixth one is yellow, and the last one is white. So the other name of green hydrogen is called no carbon hydrogen. Method what you use, that is water electrolysis, and the energy source what you can use, it may be a solar or wind. Blue hydrogen, of course, it is also known as low carbon hydrogen. It can be produced through steam reforming process. The main substance or raw material which is used is natural gas. And black hydrogen, it is also called brown hydrogen, and the method what you use to produce is called gasification. And normally we can use black or lignite coal to produce hydrogen via gasification process. Then pink hydrogen, it is also known as purple or red hydrogen. Here the method what we use, that is electrolysis, and the energy what we use, that is nuclear energy. And the next one is turquoise hydrogen. It is also known as new hydrogen. It adopts pyrolysis process, and the materials what we use, that is either methane or solid carbon. And the next one is yellow hydrogen, and it is also known as new hydrogen. The method what we use, that is electrolysis. Here we use solar power. And the final method is fracking. Actually, it is called white hydrogen. It is also known as natural hydrogen, and the method what you use, natural gas. So by this way, natural power. So by this way, we can distinguish different hydrogens by color, hydrogen by different colors. based on the method as well as raw materials used. So, how to use this hydrogen in IC engine? Actually, before going to that, one has to understand what is the working principle of IC engine. Of course, normally we classify IC engine based on the number of strokes. It may be called a 4-stroke and 2-stroke engines, and based on the method of ignition, it can be called spark ignition engine or compression ignition engine. Normally, petrol engines or gasoline engines are under the category of spark ignition engine, whereas diesel engines, they are known as compression ignition engines. In most of the passenger vehicles, almost all the passenger vehicles nowadays, the 4-stroke engines are used, not 2-stroke engines. Therefore, I will focus only on 4-stroke engines. So 4-stroke engines, of course, we have petrol engine as well as diesel engine. That means spark ignition engine or compression and compression ignition engine. In all these two engines, we use 4 strokes, namely suction, compression, power, and exhaust. All these 4 strokes will deliver one power, and they will constitute one cycle, and they will deliver one power. So, if you see the difference between spark ignition engine and compression ignition engine, petrol is used primarily. Petrol is a major fuel used in spark ignition, 4-stroke spark ignition engine, and diesel is a primary fuel what you use in 4-stroke as of now. 4-stroke compression ignition engine. The main difference between the spark ignition engine and compression ignition engine by construction wise is that spark ignition engine, it uses conventional spark ignition engines. They use spark plug and carburetor in conventional engines, but of course nowadays we use electronic injectors, electronic injection systems. And compression ignition engine or diesel engines, they use fuel pump and mechanical injectors in conventional diesel engines, but of course nowadays we use electronic injection systems in that also. In that case, actually since the petrol or petrol fuel, like petrol fuel has high auto ignition temperature or high self ignition temperature, which require a spark ignition or spark assistance or spark ignition source. So by the way, we use a spark plug to ignite the air fuel mixture of SI engine, which is supplied into that. Whereas diesel engines, normally they are high compression ratio engines. Why high compression ratio engines? Because diesel, it has relatively low auto ignition temperature or low self ignition temperature than petrol. So when it is subjected to the air fuel mixture is subjected to compression, automatically it will ignite the air fuel mixture. Therefore, the diesel engines, they have high compression ratio, and only by compression the air fuel mixture will get ignited. So diesel engines, they have only fuel pump and fuel injector, not like spark plug and either carburetor or either carburetor. So if you see this fuel wise, petrol is relatively more volatile and a high self ignition temperature, whereas diesel, it has relatively low volatility, but it has low self ignition temperature or auto ignition temperature. By the way, if you want to use hydrogen in both the engines, whether petrol engine or diesel engine, the methods are not same. Slightly the methods are different. That I am going to talk about that in the next few slides. So if you see this gases fuels for, of course, if you take this gases fuels for IC engine operated vehicles, as you know, nowadays we use LPG, CNG, all the things we use in spark ignition engines. In diesel engines, we use gaseous fuels like LPG, CNG, of course, all are used. When you use hydrogen in liquid fuel, how you have to use? When you use hydrogen in gaseous form, how you can use it in diesel engine, that you have to know. Because the method of igniting the fuel in the engine is different. So when you take this liquid fuel, suppose hydrogen, you want to use it as it is in a liquid fuel, first you have to store it in a low cryogenic temperature, and then you have to use it in the engine. It may be SA engine or C engine. Since hydrogen, it is in, let's say it's in liquid form, you can directly inject it into the engine and in a petrol engine, and you can run the vehicle. Whereas if you take a diesel engine, liquid hydrogen which is stored in a liquid form, that can be injected into the engine. However, the problem is you have to store the liquid hydrogen in a cryogenic form. That means very low temperature. So you can use this liquid fuels, hydrogen liquid form, in both SA engine and C engine as you wish. With the help of electronic injector, you can inject the fuel in the SA engine and C engine. There is no issues. But the problem is you have to store the hydrogen in a very low temperature, and you have to maintain the temperature. Of course, Tata Motors, they are working on this cryogenic cooled engines, cryogenic tanks to store hydrogen, and buses, of course. It's a big project they are doing on now. And one of my students is working in that Tata Motors. He is developing such system. Whereas if you use gaseous fuel, then that is a problem, because SA engine, as you know, how you use LPG and CNG in petrol vehicles, you have a mixer kit. You can directly use, you can send the gaseous hydrogen into the mixer kit, and like a carburetor mixing kit, there you can mix gaseous hydrogen with air and supply into the engine. And the spark plug will ignite the air fuel mixture. There is no issue at all. But if you want to use gaseous hydrogen in diesel engine, then what is the problem? Because gaseous hydrogen, of course, that the gaseous hydrogen, it is in gaseous form, it can mix with the air very well. But the problem is hydrogen, it has a higher auto ignition temperature. Then what you need? The higher auto ignition temperature require an ignition source. So what method you have to use, that I will tell you now. Gas is actually, when you use this hydrogen, you can use a separate method called dual fuel method. That means first you can start the engine with a liquid fuel. It may be diesel or biodiesel. You start the diesel engine with diesel. Once the engine becomes warmer, then you allow hydrogen along with air in the intake manifold of the diesel engine. When you do that, the gaseous fuel plus air will get ignited with the help of the warmer state what you available inside the engine. That's called dual fuel method. So people are working on to use this hydrogen in dual fuel engines, means particularly diesel engine. When you want to use this hydrogen in petrol vehicles, there you don't require a major modification in the engine. Only you need to store the hydrogen in a cryogenically cooled storage tank. But in the case of diesel engine, you need either fuel modification or engine modification. So I will show one of the ideas, one of the experimental setups in a research article. Here you see this hydrogen dual fuel diesel engine, what they have. And here if you just see, the engine is located at the center. It's a common rail diesel injection, common rail direct diesel injection. And the right hand side you can see the red color hydrogen cylinder that is there. From there hydrogen is taken and it is injected in the intake manifold. Just above that, just before that, you have a throttle valve that you can see. And below that you can see, of course, fuel injection controller and the injection driver, combustion analyzer, all are there. On the left hand side you can see this fuel tank. Fuel tank, of course, which is used to inject the fuel. As I told, if you want to operate the engine in dual fuel mode, first you have to start the engine with liquid injection, means diesel or diesel like fuel that can be injected into the engine. once you get a warmer condition, you can just supply hydrogen. You can vary the mass flow rate of the hydrogen. Either you can allow hydrogen in the form of gas. In that case, you will have to call it as a dual fuel engine. Liquid hydrogen also you can inject, of course. In that case, you can use separate electronic injector and you can inject the fuel. Then, of course, when you use this hydrogen, what are the advantages of hydrogen when you use in internal combustion engines? There you can see, of course, hydrogen is a carbon-free fuel. So there is no carbon emission. You will not get any carbon monoxide or carbon dioxide emission. And of course, hydrogen engine will not produce any unburnt hydrocarbon also. Only thing is that it will produce oxides of nitrogen emission, because when you use hydrogen in internal combustion engine, air is also another substance which you have to use for combustion process. Actually, atmospheric air, it contains the major constant as nitrogen, then oxygen, then other elements like CO2, water vapor, all will be there. So when nitrogen, which is available in the atmospheric air and it enters into the engine, nitrogen will convert into NOx during the combustion process. As a result, the internal combustion engines, when they are operated with a hydrogen fuel, they are prone to produce oxides of nitrogen. And the main product of combustion is that, of course, you get heat. Apart from that, you also get oxides of nitrogen, and one more product is water vapor or water. That means, since hydrogen, it is a two element. That means hydrogen that can combine with oxygen to form water. Therefore, in the engine exhaust, you will be able to find only these two. That means water vapor and oxides of nitrogen. Oxides of nitrogen can be controlled with the different techniques like adopting selective catalytic reduction device or exhaust gas recirculation, or you can also use clean NOx tap mechanism, or you can inject water into the engine itself. That is called water injection method, or you can use urea injection, or of course you can also have some engine modifications to reduce NOx emissions in the engine. And of course, when you see this, when you use hydrogen in a petrol engine, you may not get knocking severely, but you have to see that when you use hydrogen, how knocking occurs, you have to see that. So when you get knocking in engine due to some problem, then you can add anti-knocking agents with hydrogen, then you can reduce this knocking. So if you see this dual fuel diesel injection, hydrogen diesel injection engine, how the the flame will propagate in the spread in the engine. That arrangement or the picture is shown here. When you use a dual fuel engine, as I told, first you have to inject the diesel or diesel like fuel, start the engine, get the warmer condition inside the engine, and then of course hydrogen is allowed through the intake manifold. So that is one case, and the second one is, of course, people are trying to inject the hydrogen in the liquid form itself into the engine. Now this picture, it shows how the flame will propagate inside the engine. So diesel injector injects the fuel, initial spray development happens, then breakup and the operation of the fuel, injected fuel happens, which is surrounded by H2 air charge in a dual fuel engine. Then auto ignition of diesel occurs, onset of pre-mixed combustion occurs. Then of course the warmer state inside the engine, of course that will spread towards the engine, and the air fuel mixture, hydrogen air mixture will start burning. So by the way, of course, you will get here, if you supply very rich mixture, then you will get some traces of unburnt hydrogen, but that also can be utilized back. Then next slide, of course, it shows how this hydrogen diesel dual fuel engine. Initially, suppose if you inject only diesel, then what happens? Diesel will mix with the air and get ignited, and thereafter, if you allow this hydrogen, then of course a hydrogen flame that will propagate, and when you inject further with the second injection of diesel, this flame will continue to travel on the engine. So if you see this, the main difference between the single fuel diesel engine and the dual fuel diesel engine, pressure crank angle diagram is shown here in this picture. Actually, pressure crank angle diagram is very much helpful to identify whether the engine experiences knocking or not. So in that case, this single fuel diesel engine, that means that only diesel, when diesel is used, you see this left hand side diagram. A, the maximum pressure, it occurs slightly after top dead center. The PV just after C, point C, it is on the top dead center, and the maximum pressure occurs slightly after the top dead center. When you just look at this dual fuel mode, right hand side figure B, there you can see two different peaks happen. One is C and the second one is E. That point E is far away from the top dead center. So how you can reduce this peak? Either by changing the engine geometry, engine parameter, or you can slightly reduce the help of fuel modification. So hydrogen is a very clean fuel which will produce only oxides of nitrogen in any of the engine. It may be SA engine or CA engine, and water is also formed. Water can be of course utilized, whereas oxides of nitrogen can be regulated by adopting either engine modification or fuel modification. There is a lot of research required to incorporate these hydrogen engines in the automotive vehicles, especially in the mobility sector. So many companies, of course, they are rolling back from manufacturing electric vehicles to manufacturing hydrogen engines, because hydrogen can be produced from various sources. As I told, it may be produced from coal, natural gas, or it can be produced from different organic waste also, or it can be produced from biomass sources. So there is a lot of scope to produce hydrogen as much as possible. In near future, hydrogen production will play a major role, especially in industries. Of course, Government of India has introduced a new program, hydrogen program, which of course insists the production aspect, and the second one is utilization aspect. So if we find various options and possible routes, then we can slowly move on to introduce hydrogen vehicles in near future. India is working on to promote this hydrogen engines, especially in the transportation sector. So in research and development aspect, of course, if you try to develop different different sources by which you can produce hydrogen, or different catalysts to increase the hydrogen production in either gasification or pyrolysis or any other route, then you can get project either from Ministry of Renewable Energy Sources or CSIR, that means Council for Scientific and Industrial Research, or coal. Of course, Ministry of Coal also, they are giving a lot of money for hydrogen production. So that is one aspect, production aspect. Of course, the second aspect, how we can introduce hydrogen in a novel idea in vehicles, especially internal combustion engine. If you have idea, then that also will be encouraged by funding. So I hope the time is now to wind up. Now I finish my lecture. If you have any doubt, you can ask. Once again, I thank all the organizers of this workshop to give me an opportunity to talk about this hydrogen as a cleaner fuel for mobility. So if you have any questions, you can ask me now. Thank you for listening. Hello. Hello.
Yes, sir.
Yes, sir. Finished.
Any doubts? This session you may ask the speakers. So it was a very engaging session, sir, on the fundamentals of hydrogen and its reach for our India's potential. Even though the earlier sessions were covering the topics about hydrogen, this was able to clarify some doubts regarding how to name the colors and all, sir. Thank you very much for this session, sir. Any doubts there? Once again, I ask the audience to tell or chat,
they can
put in the
mail
chat
us.
some of their questions.
Yes, yes.
Yes, sir. I will share the email ID of yours, sir.
Okay, okay.
There is an email ID displayed here. Murugan is
Okay.
@NIT or KL.
AC.in.
Yes, sir. So thank you for the session, sir. And we hope
sir.
to
Thank you,
have
thank you.
another session also, sir. Thank you very much, sir.
Thank you very much. Thank you very much. Thank you. Shall I
Thank
leave
you,
now?
sir. Thank you, sir. Thank you, sir.
Shall I leave?
Yes, sir. You may leave, sir. Thank you, sir.
Thank you, thank you.
Yes. So audience session is ended here. There is one more session before the valedictory. Please stay connected. We'll shortly go for the session, last session of the day. Yes, sir. Any doubts regarding the session? Any clarifications you have? Thank you for the congratulations for the speaker. You convey your regards to speaker Dr. S. Murugan. Next we are joined by Dr. Hemlata. Will join shortly. Yes, ma'am. Kindly. I will add you as a co-host now, because all other are unmuting. Name, madam, like what it will start after that? Okay. Okay, make you as a co-host, madam. One second, I will introduce since sent me some files. Very good. Yes. Okay, the last session of today is going to be presented by the energetic personality in the mechanical engineering. Has got years of experience. It is my privilege to introduce Dr. K. Hemalata, who holds the head of the Department of Mechanical Engineering at Sri Manakula Vinayagar Engineering College, Madagadipat. He has over about 25 years of experience, and her academic experience is including the domains of thermal engineering, as well as making people towards the sustainable technologies, particularly these green energy technologies. So, I warmly welcome, Madam. You can have your own interaction, introduction about yourself. Yes, ma'am.
Thinking, sir.